Okay, I thought we would do, I'm going to try to put 6.3, most of it on a video, in case we don't have time to do this in class. If you look at 6.3, you don't start, 5 through 10 is where we start, okay? The other one was just asking, what does it look like? And I just didn't feel like messing with that. So you got this figure, and you've got angle 1, angle 2 is actually supposed to be representing your dashboard. Here's angle 3 and 4. Question 5 says, which angle corresponds to angle 1? Well, that's angle 3, isn't it? Actually, I wish I had drawn this more carefully. This is they're supposed to be, the wiper blades are like that. They always stay parallel when they're on your car, don't they? They stay on and they wipe parallelly. I don't know if that's a word. Angle 1 and angle 3 are corresponding angles, and they're always equal. And that's what 6 says. 6 says if the angles always stay equal, why are the wipers always parallel? And that's because we have that theorem that said two equal corresponding angles mean the lines are parallel. So the wipers are the lines here is what you would be doing. Okay, for 7, what are angle 2 and angle 3 called? Those would be same side interior angles. And you may have to pull back out your notes, but remember when we had, if you looked at it like this, if this were 1, 2, 3, and 4, 2 and 3 are on the same side of the transversal. Here they are. They're the same side of the transversal, and they're on the interior. So they're same side interior. If these two angles are, what are angles 2 and 3 called with respect to A, B, and C? They're called same side interior. That's all for number 7. Number 8, if these two angles are always supplementary, why are the wipers always parallel? Well, there was the theorem that said if your same side interior, remember same side supplementary, remember how I told y'all that when we were taking notes, if same side interior angles are supplementary, then the wipers, or then the lines are parallel. So, and that'd be another way of proving those wipers are parallel, okay? And we keep going. Name another pair of angles that if they were equal would ensure the wipers are parallel. Well, we have another pair of corresponding angles, don't we? That's angle 2 and angle 4. They've only lettered these 4 angles, so that's really the only thing we've got to pick from here. 10 said, if angle 1 and 4 are supplementary, does it follow that the wipers are parallel? Yes. Those would be same side exterior angles, and if same side exterior are supplementary angles, then the lines are parallel. I'm not sure if the book gave you that theorem, but most books do. If it didn't give it to you, it would be easy to prove it. I don't know if I see that in your book. They didn't give it to you. But if 1 and 3 are corresponding and 3 is supplementary to 4, then 1 and 4 are supplementary. So if they're kind of working backwards from that idea. If 1 and 4 are supplementary, that means 4 is also supplementary to 3 because it's a linear pair. So since 1 and 3 would both be supplementary to 4, that means 1 and 3 are congruent, and since they're corresponding angles, the lines are parallel. So you could actually go through that proof, and that'd be the steps you would take. But a lot of books actually just outright give you that theorem, so you don't have to kind of go through that every time you have supplementary same side exterior angles. Exterior is what we were talking about here. I'm just going to do as much as I can on a video. Number 12. Okay, so these problems on 12 through 18, they're asking us, they're saying, okay, exactly 1 means there's at least 1 and no more than 1. And so they've got a bunch of statements here, and they're about things we've studied in geometry so far. So we're supposed to put the words at least, no more than, or exactly in the blanks, okay? So I thought we'd run through this really quickly. Again, you're trying to do this on your own, but if you're stuck or if you're absent, this would be a good backup plan here. A line segment has exactly one midpoint. There's only one place you can cut that thing in two and have two equal pieces. So that's exactly one midpoint. Okay. 14, an angle has how many rays that bisect it? Okay, now, really, if you think about it, it depends on what they want to call. Well, no, it has to be exactly one. There's only one that's going to cut it in half, isn't there? I can't draw it. I mean, I could talk about having a different endpoint, I guess. I mean, I could say, oh, I've got a ray that does this, and it starts there and goes there, or maybe it starts here and goes there. So in that sense, you may want to talk about different rays that way, but it's got to go through here. So it'd be interesting. I don't have the teacher book with me. It's at school, so I can't really look at it to check to see what he wrote. But it just depends on how particular he wants to get with that definition. As far as if he wants to just talk about where the different endpoints are and have, infinite rays that could do it, but it's actually got to go right along that red line there. So I'm just going to say one, just because that's really the gist of the idea. Yeah, we could draw a line and we could start it anywhere we wanted to, but I'm just going to leave it at exactly one. And if he says something else in the book, you know that he's just talking about where he wanted to put the end point of the ray, I guess. Okay, 14. A triangle contains blank right angle. Oh boy, the thing's flipping on me. It contains no more than one right angle. And the reason is, if you think about it, let's say there's a right angle here. Well, all those degrees have to add up to 180 degrees. You just took 90 degrees out of it when you made one right angle, so that means you've got 90 left, but you've got to split it two ways. You've got to have the three angles, so there's no more than one way to have a right angle in a triangle. Okay, 15 is kind of a definition from the very beginning of school. Two lines intersect in exactly one point. It's not a line if it gets all curvy so that it intersects in more than one point. Maybe this thing comes back up here, but those aren't lines. We're talking lines are straight, okay? They intersect in exactly one point. The fact that we're so limited sometimes on things is a good thing. It helps us know for sure that in our proofs that we're not making up stuff and maybe there was another case we didn't think about. Lines are perpendicular if they form, I'm going to say at least one right angle. Usually if you've got two lines, they're going to form four right angles. So if you're talking about no more than exactly or at least would be the best choice there. Most of the time there's four, aren't there? Because if that's a right angle, the vertical angle's a right angle, and then if they're linear, you got a linear pair. If this is 90, the other one's 90, which means that's a right angle, and then its vertical angle's a right angle. If you had line segments, you could have line segments like that would make exactly one angle, but this said lines, so we're going to go with at least one right angle. Okay, 17 says through a point on a line, so let's draw a line. Here's a point on a line. There is blank one line perpendicular to the line. There's exactly one. I can't come in here and draw it any other way. It's just one thing there. That's why when we do our construction, if you remembered, we started here, swung it out here with our compass, and we put our sharp end here. We swung it out here. And it's where those two marks crossed was where we drew the perpendicular line. There's exactly one. There's not another one hiding anywhere. Okay, and then 18 through a point not on a line. There is blank one line perpendicular to the line. Again, this is exactly one. You can kind of see it in the diagram above. If we had this point, I can't go like this with it or like this with it. It's got to go right down through to this other point to be perpendicular. So there's exactly one there. 25 says Euclid made the following assumption. If two lines form interior angles on the same side of a transversal whose sum is less than 180, what he's saying, if you add 1 and 2 together, it's less than 180, then the two lines are going to meet. The deal about it is that angle 1 and 2, they have to be supplementary. If they're not, those lines aren't parallel and they're going to meet. So that's kind of what he's getting at in that pre-part here. So now he draws a diagram. I was just kind of making a diagram to go along with what he said in the theorem, the kind of the intro part. At 25, and we want to draw those, I'll draw that diagram. It says the figure above shows 4 lines intersecting at 4 points. How many of these lines can be considered to be transversals? Well, actually all of them could. There's all 4 of them because, you don't have to have a parallel line to have a transversal. So if we look at C and D, B would be a transversal to C and D. A would be a transversal to C and D. If you look at A and B, D would be a transversal to A and B. They're not parallel, but still they're transversals. And then if you're looking at A and B, C and D both, each one of those would be transversals. Okay, so there's 4 there. They're not parallel. The lines aren't parallel, but that doesn't mean those aren't transversals. So it says copy the figure and write the measures of the other angles surrounding each of the 4 points. Okay, so even they're not parallel, so we can't use that idea to find the answers, but what we can do is use the idea of linear pairs. For instance, this right here, that has to add up to 180. Those 2 angles there have to be 180, so this is going to have to be 180 minus 99 would be 81. Trying to subtract in my head. I don't have a calculator, and you know how that goes sometimes. And similarly, this one right here would have to be 101 from 180 would be 79. Now, the fact that I can find those 2 angles using linear pairs, already I can find, because this 79 is across from where I'm writing this blue 79, we can find those because they're vertical angles. And similarly over here, since we have 81, we have a vertical angle over here that's 81. Let me use some green. The vertical angle to that 99 degrees would be right here, so that's 99 degrees. The vertical angle to this 101 would be right here. So we can fill in all these angles. Up here, 102 has a vertical angle right here, doesn't it? And 101, 100 degrees has a vertical angle over here that's 100, so we can fill those in. And now all we got to really do to finish this up is look at some linear pairs here. These where I drew the purple arc, those 2 angles together make a line, so they're a linear pair. So you could say 180 minus 102 would give you 78 degrees. And since that's 78, you can fill this in as 78 because it's a vertical angle there. Now over here, let me pick a different color just so it would be easy to tell where I'm looking at. Let's look at this kind of lilac color I'm putting up here. There's a linear pair because those 2 angles together make this straight line, right? Their outside rays form a straight line. So 180 minus 100 is 80 degrees. And since that's 80 degrees, then the vertical angle to it is 80 degrees. So we can fill those in really quickly. And that's all they wanted you to do into 26. To 26. And then we just stopped there.